Welcome one and all. The Department of Geography, Sorsuna College, Kolkata, is celebrating the GIS Day 2023. Since GIS is a very upgrowing and contemporary field in the domain of science and technology, so this year college has decided to reach beyond the graduate and postgraduate students. This video presentation is getting recorded to popularize the concept of geographical information system among the school students. Basically, this video is intended to give an overview especially to the school students regarding the concept and overview of GIS. This video is not prepared for any GIS expert. Rather, this video will give an insight to the school students who are just getting introduced to this new technology, or who are having very keen interest to understand to learn the concept of GIS. So in this video, I will be discussing the concept of GIS and the significance of GIS in today's world. We'll explore the history of GIS and its evaluation into a full-fledged scientific discipline. So it doesn't matter whether you are already familiar with the uh, concept of GIS or not. Uh, but we'll try to, in this video lecture, we'll try to provide a comprehensive understanding of this field. So, without wasting any further time, let us dive into the discussion of GIS. So, just have a look to this slide. So, basically, what GIS is, let us try to understand in a very easy manner. I have given some graphics or picture of a few elements here. So, first one is map, second one is analysis, third one is the data, fourth one is the software. So fifth one is the satellite, sixth is the carrier, and the last is the apps. So we know what map is, we know what is analysis, we know what is data, we have a concept of software, we know satellite, what is satellite, we know what is applications. Like in today's world where we are always attached to a PC, whether we are always carrying a mobile phone, rather I should say where we are always carrying a smartphone in our hand, we all are using the GIS, okay? Whether by knowing it or by not knowing it, but we actually are using GIS in our daily life.
So, before we discuss further in detail about GIS, so let us quickly look back to the history of GIS. So, before coming as a full-fledged science, GIS was existing since a long time. So, but within the last 5 decades, GIS has evolved from a concept to a science, a full-fledged science. The phenomenal evolution of GIS from a rudimentary tool to a modern powerful platform for understanding and planning our world is marked by several key milestones. So let us go one by one. Let us start with the early history of GIS, that is in 1960. So the field of geographic information system started in the 1960 as computers and early concept of quantitative and computational geography emerged. So early GIS work included important research by the academic community. Later, the National Center for Geographic Information and Analysis, led by uh, Michael, he formalized the research on a key geographic information science topic such as spatial analysis and visualization. So next, we can go to 1963. That is a very important year when Roger Tomlinson, you can see his photograph in the right hand side. So he coined the term GIS for the very first time. Okay, and he developed the Canadian geographic information system. Um, and like he developed the first computerized GIS system in the world in 1963. So the Canada government had commissioned Tomlinson to create a manageable inventory for natural resource and natural resource management. So later on, Mr. Tomlinson developed certain programs using computer. He tried to fix up a large data sets, and he automate the computing process for a large data sets, and which enabled Canada to begin its national land use management program. He also gave, as I told you at the very beginning, he also gave it as a name as GIS, that is Geographical Information System, right? So now we can move to 1965, just after 2 years of Tomlinson. So the Harvard Laboratory, the Northwestern University in 1964, Howard Fisher created one of the first computer mapping software, which was known as SciMap in 1965. He established the Harvard Laboratory for Computer Graphic, while some of the first computer mapping software was created and refined at the lab. It also became a research center for spatial analysis and visualization. So you will get this spatial information, spatial analysis everywhere, as I told in the very beginning. So it is also known. So that's why GIS is also known as a spatial science. So now we can move to 1963, 69. That is a very important year. In 1969, ISRI was founded. So ISRI, you might be knowing or might not be knowing, but if you come to the career of GIS, you would definitely would be knowing about ESRI or ISRI, because it's a leading company in the world who is dealing with the GIS technology, and the famous software which is used by each and every GIS personnel, that is ArcGIS, ArcGIS desktop or ArcGIS server. It was founded by the ISRI, right? So the Jack Dangermond, a member of the Harvard lab, and his wife, so they founded the Environmental System Research Institute, INC, that is ESRI. So the consulting firm applied computer mapping and spatial analysis to help and use planners and land resource managers to make informed about the decisions, okay, or for the decision makings. The company's early work demonstrated the value of GIS for problem solving. History went on developing many of the GIS mapping and spatial analysis method, which are still now in use. So these results generated a wider interest in the company's software tools and workflow that are now standard to the GIS. So that's why we call it a ESD package. Okay, so ESRI SEP files. So many formats also got introduced with the hand of ESRI, right? Uh, Now, in after 1981, GIS goes on a commercial platform, and as computing became more powerful later on, ESRI improves its software tools, working on projects that solve real-world problems, led the company to involve and develop about GIS tools and approaches that could be broadly used. Right. So ESRI worked gain recognitions from the academic community, and as well as from the researchers, the market entrepreneur. So afterward, indeed, of analyzing and increasing number of projects more effectively, came to ESRI, and ESRI developed ArcInfo, as I was telling you, ArcInfo. Nowadays, it's known as ArcGIS. It's a foolproof commercial product for the GIS community. And nowadays, you see, GIS has gone to a different level, right? So in our daily life, in every sector, GIS is getting used. But sometimes it's getting used in the name of a different package or different software. But still, if you go deep into the technology, you will be seeing that it's actually using the GIS technology. So maybe might be WebGIS, which is launched in a web platform, and it might be an interactive form of WebGIS. So whatever it is, basically the core system or the core solution is coming from the GIS technology, right? So let us look at the terminology, and let us try to understand one by one. So what is a GIS? So let us go one by one. So geographic information system or geographical information system. So what is geographic here? So geographic implies that location of the data or location of the item or location of any feature. So it can be calculated in terms of latitude, longitude, or a geographic coordinate system. So let us try in a very easy manner, right? So this is our globe. All of you know that it is a basic geography. So we what do we have? We have x-axis and we have a y-axis. So x-axis is this one, that is your equator, and y-axis your, like your prime meridian, right? So all the x value that you put here, so like 1 2 3 4 5 6 up to 80, okay? So these are all x values, right? So these are all what? These are all longitudes. And what is the latitude? Latitude is the y, right? So latitude is the y values. So you go from 0 to 90 on north, and you go from 0 to 90 in the south. So what I'm trying to make you understand is, so you take any continent, you take any place, you take any country, so that is having a geographical extent that we know very well. So let us take an example of India. India is having a geographical extent starting from the northern part, from the Kashmir to the southernmost part, that is, like your Kanyakumari or Indra Point, whatever you say. So it is having a geographic extent. So likewise, each and every object on the earth, okay, that is existing on the earth, we can denote or we can give a unique identity to each and every object in terms of its coordinate. Coordinate is what? In terms of its latitude and longitude. Say for instance, you were studying in Jadavpur Vidyapit, right? So Jadavpur Vidyapit is having many buildings. So let us take an example of a single building. So that building is having a geographic coordinate, or if you say more precisely, if you take the four corner of the building, that is having a unique geographic coordinates, right? So unique geographic lat long. So that cannot be duplicated, right? So it's like a unique ID. So likewise, in a GIS environment, the beauty of the GIS environment is we can assign, we can refer that object to the actual earth, okay? So that's why map has become interactive in that way, because in earlier days, what we have seen the hard copies map of hard copy of the map, or the printed copy of map. So those maps, actually, what if you want to read that map, so you have to go manual, which city is existing, where, like, suppose you take an example of any city like Kolkata or Bhopal, right? So you go manually, like, okay, Madhya Pradesh, or you go West Bengal. Okay, in the West Bengal, in the southern part, there are these districts are there. So in that district, district headquarters are here. Likewise, you go. But nowadays, you don't have to go to, I mean, like, you don't have to go in that way. So what you can do, you can simply search, like you search in a Google Map, right? So let us take an example of Google Map. So I hope that you all are using Google Map nowadays for your navigation, for normal, like normal, for knowledge base. So if I just want to search Jadavpur University here, so I can simply type, right? So simply I can navigate to the particular place. Okay. So this is possible because of this map is georeferenced. Okay. So now there is a new concept that is getting introduced, or that you should know in while studying GIS, or while knowing about GIS, that is georeference, or geospatial data, or georeference data. Okay. So basically, georeference data is what? So you can relate your data with the actual earth, where they are existing. I mean, say for instance, like, take the example of this Jadavpur main road. So this is georeferenced. I mean, if you move your cursor, or if you go to a particular corner of the road, the lat long which is showing here, that is a this is the lat long of this particular place. So if you go to the actual point in the earth, so you'll get the same lat long. So that's why we call it it's a georeferenced map. So, like, you don't have to go by this way, like, okay, Bardhaman, then at a particular place or a particular town. So you can simply search, because the entire thing is loaded in the database. So I'll come little later in detail. So that is all about geographic. Okay, so we call it as a geographic data or geospatial data, or like georeference data. So geospatial means what? Here two concepts are there. One is geo, another one is spatial. So spatial means here it talks about space. Space doesn't mean that we are talking about the like antariksh space, not that. Space means it's having a particular location on the earth, right? It's consuming a particular place in the earth, and that place is referred in terms of latitude and longitude. So that is all about geography. Okay, I hope I am able to make you understand why this geographic term is there in geographic information system. So second is information. So that implies the data in a GIS are organized to yield useful knowledge, often as colored maps or images, but also as a statistical graphic tables, various on-screen response, on-screen response that I have just shown you, that you can simply type the name, that which city you want to go, or in any particular building, any particular marketplace. So the map is more interactive. So that's why we are calling it as a on-screen response, because you don't have to go manually, right? Even if you can get an on-screen response in terms of thematic maps, or in terms of attribute tables. I'll come little later what attribute and the spatial or non-spatial data is. So basically what we can do in a GIS environment, we can go for making a queries. Okay, we can make our custom queries. So that's why we call it a information, because like in geographic information system, map and the database is just playing acting together, right? So database is in your backend and map is in your front end. You are interacting as a human being or as a user. You are interacting with your map, and database is like they are doing their own job in the backend, right? And the system. So system implies that a GIS is made up from several interrelated and linked component. As I said, so interrelated means here spatial and non-spatial. Information are interrelated. So whenever I call a spatial or non-spatial, it means that you know in a GIS system, there are two different type of data. Basically, we can divide data into two part. One is spatial, another one is non-spatial. So what is spatial? Say for instance, I take a name of a place, Jadavpur University, right? So this is having a spatial location. Okay, it's located in Jadavpur, or in if I go more precisely, it is having such some kind of lat long. It is having some kind of latitude and longitude extent. Okay, this is situated on beside the Jadavpur main road. So this is all about spatial. It talks about location of that particular place, right? And whenever I talk about non-spatial, that is the attribute data. We often call it attribute data. Attribute means what? So how many students are there in the university? How many departments are there in that university? What are the number of buildings? How many professors are there? Okay, how many research scholars are there? So all this information can be tagged with your spatial data. So that's why we call it a non-spatial data, or we call it as an attribute. So basically GIS is combination of that spatial and non-spatial table.
So, map is a very integral part of GIS because all the data that you input to a GIS environment, you analyze in a GIS environment. Okay, you try to manipulate your data in a GIS environment, but ultimately at the end of the day, the form in which you see your data, that is in a form of a map, right? Sometimes you see your data in form of an attribute or in form of a database or in form of a table, but the that most effective way of showing your data in a GIS environment is in a form of a map. So basically, a map is a representation of geographic feature or the other art feature or the spatial phenomena by graphically conveying information about the location and attributes. You know that we used to show the art feature in form of a maps, like whether it may be a building, it may be a road, it may be a land use, it may be it may be anything else, right? So we show it in a form of a map. Now, there is another science that is called cartography. So, cartography is basically a map, art and science of map making, right? The people or the scientists or the technicians who actually make the maps. We call them as a cartographer. But nowadays, cartography is, it's outdated concept because we have converted entire cartography to a digital cartography. So there are no manual cartography nowadays. Maps are not maintained in a manual mode right nowadays. In earlier days, like if you go to the prehistoric age or history time, like when Vasco da Gama was there, and Columbus was there, so they used a naval chart or maps to find out different places of the world, right? But thereafter, over the period of time, like physical maps or the, like indicative maps or the mental maps has evaluated in a far away. So nowadays, all maps are digital maps, right? So you all are familiar about digital maps, like you nowadays you are using Google app or Google Maps. So they all are digitally made, right? So these are all digital map. So this digital map has given an era to a digital cartography. So we can also call it as a computer-based or computerized cartography. So performing cartography function by means of computer hardware and the software. So it's basically integration of computer hardware and software to prepare a better map nowadays. So let us just understand that how like how we are using GIS every day. Just think about Ola, right? Or just think about Swiggy, that is delivering the food to your doorstep. So how is this possible? Just think about it.
Let us take an example of your famous app cab Uber, right? So how does it work, or how it is acting exactly? So you basically, you first of all, you go to your app, or you search from a browser. So in your mobile or in your smartphone, you just open the app, and you start with giving source and the destination station, right? So source is automatically detected because you have a uh, uh, technology in your mobile that is called GPS. So we all know about GPS. It stands for Global Positioning System, and it is also, let me tell you, since we are talking about GPS, so it is also an integral part of your GIS system, because GIS is all about your location service. So nowadays location service is very important, right? So anything can be located in terms of its latitude, longitude, and altitude. If you tag a GPS chip, or if you tag a GPS motherboard with that particular device, suppose your mobile phone, it can be tagged with a GPS device. Or suppose you take example of a PDA, you take example of a vehicle, your car can be, your car can come fitted with a GPS receiver, right? Or GNSS receiver. So once it is having the capability to track its own location, receiving the signal from the GPS satellites. So you can plot that object, or you can plot that yourself, or you can plot your car on a georeference map. As I was telling you, that Google Map is a georeference database, where you have the interactive map in the front end, and back end the in that database is playing a role. So likewise, you take an example of Uber. Suppose I want to ride Uber or a app cab. So simply what I do, I go with a search in the destination and source in the destination station. Suppose I want to go to, I'm in Howrah station right now. I'm in Howrah station right now, and I want to go to Netaji Subhas International Airport, Dum Dum. So what I do here, simply I am giving an input to the system that this is my current location, and I want to go to a particular location. So I can simply go for searching the vehicle. So once I search for a service, what it does, in the back end, the many things are working. See, interactive map is opened up, right? So, and on that map, it is trying to find out the shortest path and the fastest route with which I can reach my destination. Okay, so I want to start from Howrah station, and I want to reach Kolkata airport. So see, there is a black line, and with that, it has been, I mean, it is showing a shortest path. Okay, so I can simply start from Howrah railway station, then I can just cross the Howrah bridge, and then I can go via Kakurgachi, and I can take the in the Damdam and the VIP road, and via Bagviati and via Koikali I can reach the station. So this is my this would be my shortest route. And at that very moment, the Uber has also started searching for the vehicle. So you'll be seeing that what are the all vehicles that is available around. So once you confirm your journey, so the willing vehicle, whoever the driver is, who wants to go to, I mean, whose criteria matches with your requirement, so he'll be responding to you. So with that, what I make you understand is, what I'm trying to make you understand is, see, this is basically getting possible because of an entire foolproof GIS system is working at the back end, and entire database is working in the back end. So first of all, what it does, it picks your location, then it sends to a server, then server is also having the vehicle location around you, so it communicate with the available vehicle, and it sends you a message that okay, this is the vehicle that is willing to go to your particular destination. But this is what I'm trying to say is, this is all because of, this is possible all because of this interactive map or this georeference map. Okay, because whenever you will be starting your journey, you will be seeing yourself that you are moving on the map. So this is basically your this is basically what GIS is playing a huge role here. Okay, same happens with the your food delivery app like Swiggy or Zomato. So there are a number of examples. So I just wanted to draw a live example here. So next, let us understand what is GIS mapping. So we have seen the maps, we have seen the interactive maps. So let us understand why and how the mapping is done, or what is GIS mapping. So GIS mapping is basically, it is a visualization of geospatial information. So the main four ideas of geographic information systems are creating a geographic data. As I told you, that data should be having a foolproof locations, or data should be related to your original earth, right? So in terms of what? In terms of a datum, in terms of a projection, we all know about projection. So basically it's a procedure of, like projecting your 3D earth to a 2D piece of paper, or 2D platform, or 2D mapping environment. So we can relate the earth object to be referenced with the actual earth locations, right? Then manage it in a database. So as I told you that the beauty of the GIS is, you don't only have the map, you always having a map, and at the back end you have the database. Suppose let us take an example. Here I'm showing a river. So I have digitized the river over here, but once I select this river, so in the back end the attribute table will be also selected. I'll come up with a live example. The third one is analyze and find patterns. So we can analyze and find the patterns in a GIS environment. And the last one is the display it on a map. So we can simply display over a map, interactive map or map. Because viewing and analyzing data on map impacts your own understanding of the data. That is very true. And we can make a better decision making using a GIS, right? So there are few technologies that is integrated with GIS, or that supports the with the GIS environment. So first of all, the topmost is remote sensing. That's why you might be knowing, or you might have seen that all the degree courses, or if you go for MSc or if you go for MTech, all the degree courses comes with a integrated subject, that remote sensing and GIS, because remote sensing is a integral part of GIS, or in a better way I should say that the all the source of input that GIS is having. So remote sensing is one of the best source of data input. So what you might be asking yourself, that what is remote sensing. So remote sensing is basically acquiring information. It's a process of acquiring information of any earth object, or any earth phenomena, or any terrestrial phenomena, without coming contact without coming physically contact with a, particular area, object or phenomena, uh, but rather with the help of a sensor or with the help of a device. We often call it a sensor. So basically, you take an example of a satellite data. Okay, so satellite is moving around the Earth, or satellite on is placed on your over your head, almost 700, 800 kilometer, or sometimes more than that. If it is a remote sensing satellite, then it's placed on from 700 to 900 kilometer on the Earth surface. So from there itself, it is making an observation on the what is happening on the Earth. If there is a cyclone, it is taking the image of that cyclone. If there is a land use change, it is taking up the it's taking the picture of that land use. If there is a mining activities, it's also taking the image of that mining activity, and each and everything. There are a number of examples. So remote sensing is a basically a main source of data input to the GIS environment. So next is the photogrammetry. Photogrammetry is basically a surveying or mapping. Basically, photogrammetry is the making of measurement or making of mapping measurement using a uh, using photographs or using image. So we call it as photogrammetry. Then cartography. Cartography, we have already discussed that cartography is basically art and science of map making, right? Then we have CAD, we have geodesy, surveying, mapping, GeoICT, geospatial information communication. There are a lot of things like IoT, right? So where we can use it, like we can, there are n number of application. Let us start with the geoscience. Then we can use it in civil engineering, like construction. We can use it in transportation. The same example I have just shown you. Okay, we can use it in natural resource management, like say for instance, your crop assessment, your forest assessment, forestry assessment. We can use it in geophysics or geological application for geological mapping. Okay, for mineral mapping. We can also use it in environment planning, administration, right, management, business. So now we can simply, if someone asked you, you can simply define GIS in a single line. That is, GIS is basically it's a computer-based information system that used to store, capture, and analyze geographic data or geospatial data for better decision making, or for some kind of analysis, or for some kind of planning, right? So this is all about geographic information systems. So at the process of GIS actually gave entirely new response, response to or new insight to look at the data or look at the map, right? And the interactive, the interactive uh, interface can help you or can give you opportunity to see to visualize the data in a very different manner, whether it in terms of in a spatial manner or in terms of a non-spatial manner. If you look at the foolproof GIS system, it is a combination of few components that I have shown in my slide. So first of all is the data. So whatever you do, wherever you do, whenever you do, so data is the main component. You have the data, you have a geospatial data, you have a digitized map, so you can simply bring it to the GIS environment. The second one is the method. Okay, what method you are actually going to use to manage your data, to analyze your data. Third one is the people, or I can say that it's user. The user community is very important aspect. So whoever the users are, maybe you might be an expert user, you might be a beginner, you might be a mid-level professional, but user is very important. Okay, and the next one is the hardware. So as I told you that, that's because after hardware there is software. So software is all about your computer application that is that will help you out to handle the data in a GIS environment, or to handle the geospatial data or georeference data. And to run this software, you need a hardware. Definitely you need a hardware, whether it's a mobile application or it's a desktop application. For if it is desktop application, then you need a desktop with a competent hardware. Or if it is a mobile application, you can also use it in a mobile application. Then your mobile should be capable of handling that particular or holding that particular data, or it should be supporting certain kind of features. So that's all about the component of the GIS.
So next, let us come and just quickly understand some basic function of GIS. So I have just shown a point here. So what is it? Okay, so it's a point. It might be denoting a particular location. It might be denoting a particular place, or it might be denoting a particular art feature, right? Whichever it may be. So it is a location, basically. So now I'm saying that what it is a JFM area. So it's a JFM is a terminology is related to forestry. It stands for Joint Forest Management. So basically, we are trying to show here a JFM village. Okay, so we call it a Joint Forest Management Village. Now, next is what is its location. So as I told you in my previous discussion, so you might have remembered that a location can be represented in a GIS environment in terms of its coordinate. In coordinates is what it's in terms of its X and Y location. So more precisely, I can tell you that in terms of latitude and longitude. Sometimes we also add the Z coordinate, which is altitude again, but here we are not discussing that. Now, where it is on the particular X and Y. Next, condition. Condition is the within the forest block. So the magenta color box or the is the forest block, and it is within a particular forest block. Next, how was it changed? Okay, what is the trend? So improvement in the forest growth in last 5 years. So we just try and understand. I'm coming one by one. What is it? It's a location. It's a JFM area. Where it is within a particular forest block, right? Then how was it changed? What is the trend? That improvement in the forest cover. So along with the spatial data, along with the spatial location, I'm going to add some non-spatial data. I'm going to add add some information with the location. So that is the main functionality of GIS. Now next is what? Which data are related? Patterns. So answer is the nearest JFM village, right? Next, what if models? Okay, finding solution to the fourth question. So this is how basic function in the GIS work. So I'll try to relate the same with a live example just after showing you two more slides. So as I told you, the data in the GIS environment, basically two types of data. One is spatial data and another one is the attribute data. So spatial data is the spatial location of any feature that is in terms of X and Y, and the attribute data is the non-spatial data or the information or the attribute that is attached to a particular spatial data. Next, one more important concept is spatial data can be in terms of raster and vector. So here I'm going to add a very important concept that is, and that you will find in the GIS environment. So data can be stored in form of raster or in form of a vector. So now what raster is? Raster is basically storing the data in terms of a pixel information. Okay, pixel by pixel representation of data or pixelate information, pixel by pixel storing a data in terms of a pixel by pixel information. So basically, we are talking about image. Let us take an example of raw satellite image. Okay, so how does it come? It comes in the form of an image. So that's why we call it a raster data. But then again, what is the vector data? Vector data is basically, it might be a new concept to you, but it's basically storing a data in a GIS database in terms of three major entity. So what are the three major entity in GIS? That is in the terms of point, second is line, and third one is the polygon. So here I have shown a data model and the structure that you can keep that you can keep in a GIS environment. That is the raster model and the vector model. Look at this chair I have shown here. So in first image, the chair is in terms of the image. Okay, it's pixel by pixel information. But in the next model, it is in a vector. It is in so it is shown in the polylines, lines or polylines. Let me give you a live example of that. So this is actually basically a GIS software. It's basically ArcGIS. As I have mentioned in the earlier discussion, that Easily is having its major product, that is ArcGIS. So basically, it's ArcGIS. Let me just open the data again. So this is a raster data basically. It's an image. You can look at the format. It is in TIFF format. Okay. So TIFF, IMG, these are all raster formats. So I'm opening the data. So this is just a scanned map. You can compare it with a scanned map. Like suppose I am having a hard copy, I have scanned it, I have made it in a soft format, and I have imported the same data to a GIS environment. If you zoom it, you will see that it is storing the data in pixel by pixel environment. See, all are different colors pixels. Okay, I mean to be very precise with that, all the pixels are having different color intensity, right? So these are all pixels. So here you cannot perform any kind of you can perform, but your performance or your analysis will be too much restricted. So in that way, you have two different kind of GIS. One is raster GIS and another vector GIS. But since this is a raster, this is only an image, so it is storing the information in terms of pixel, right? It's a map of West Bengal and it's an image. Now, what is vector again? So if I rectify this data, if I georeference the data, and afterward, if I digitize the data, so it can be digitized and further it can be converted to a vector data. So how it can be digitized? We can use three different entity for digitization. That will be point, line, and polygon. So here all the districts are in shape of polygon. So we will be using polygon feature to digitize the same. Let me show you a simple example. You might have seen Google Earth nowadays. Uh, just
So we have landed in the Google Earth application. Yes, some of you might have seen Google Earth or might have used Google Earth for your school projects. So basically, it's an application, and it's a virtual globe, which is meant with the by stacking mostly different high resolution data, uh, high resolution satellite data, basically. So if you take an example, or if you go any place, just like, say for instance, I'll go to my own city. So there is a stadium. Okay, this is a famous Salt Lake Stadium. So this stadium can be very clearly visible, and see, it can be though it's an image. So here it's a representation of pixel by pixel information. If we zoom very much too much up to the infinite level, so we'll be seeing that it's pixel by pixel information. But basically, if we want to, instead of raster, so this is basically a raster, but if we want to make it as a vector, so we can represent this in terms of a polygon, right? How we can represent this? We'll simply take a polygon tool and we can digitize it. Digitizing means what? Digitizing means what? We can simply draw a vector, right? In terms of polygon, we can represent this in terms of a oval shape polygon. Or if it is a square, then we can draw a square shape, whatever it is. But this is how the main motto is. This is how
we can represent this. Okay, instead of fields, we can simply go for outline. We can give a glaring color to it. So that's it, right? We can give some glaring color, pink. Let us go for three. Okay. So the best part is now what we can do. See, in raster we can just only visualize it, or visualize the stadium, and we can just have some information. But once we convert this information to a vector, convert this to a vector, we can make a measurement. See, this is, if we go for square meter, so this stadium is having area of 58,662 square meter. Okay, and the perimeter is 873 meters, right? So this is a, it's very useful for mapping, right? So once you have this vector instead of raster, if or once you convert the raster data to a vector data, you can simply make a lot of information out of it, right? Likewise, if you want to digitize the road, so here are, you can see the roads are clearly very visible. Even you can see the vehicle as well. See, in the buildings, vehicle. So we can also digitize the buildings one by one, right? We call it a building footprints. We can digitize the building. Okay. Likewise, we can digitize the every building. So this is a way of converting the raster data to a vector data. So this is example of polygon. So now if I try to draw an example of line, we can simply make a line for this road. So road can be represented as line. See, so this road is for going towards this area. I mean, this is a up road, and this is a, sorry. So this is one road, and this is the down road. So it is like this. And the good part is we can also, again here we also, we can make the measurement. So this is 0.45 kilometer, right? Or in meter we can 453 meter. So we have seen an example of polygon, and we have also seen an example of line. So what may be the case of point? So point data might be your, suppose you want to mark a tree, right? So you can mark it as a point, right? Suppose this one you want to mark, this tree you want to mark, so now you can point it as a tree. So basically, to represent the earth feature or to represent any feature in a GIS environment, you can use three entities. The first one is the point entity, second one is the line entity, and third one is the polygon entity, right? So, and again, this will also depend on your data scale. So scale is very important. In map, scale is basically represented as is the ratio between the map distance and the ground distance. So scale is very important. This same stadium that I'm showing you in the polygon feature, this can be represented also in a point feature if I just zoom this out. So if I go for this kind of zoom level, so it, instead of now it is, instead of polygon, it will be a scale. Sorry, it will be a point feature. So see, now the scale, I have reduced the scale, right? So now this particular stadium, now it has become a point, right? So we can now represent this as a point. So if I try to make a map of entire Kolkata, and there I want to show the Salt Lake Stadium, so it will be a point. But again, if I zoom it up, so if I now
want to show the Salt Lake area as polygon, then here you can also represent your stadium as a polygon. So here I can map the entire Salt Lake area as polygon, right? This is very famous Salt Lake area of Kolkata. Some of you might be belonging from this area. So this is a polygon, right? But at the same area, if you want to show in entire West Bengal or in entire Kolkata, the same area, instead of point it will become a, sorry, instead of polygon it will become a point. So suppose I can zoom out. Now it is a point. You cannot make it in the polygon format. So it all depends on your scale, right? So I hope I'm able to give you some idea about the point, line, and polygon, right? So now next move to the previous example, the previous thing, the raster and vector data, as we were discussing earlier. So again, I'm going back to the ArcGIS software. So here I was discussing about the raster data, where I have imported raster data of West Bengal, or the map of a normal scan map of West Bengal. But what I have done further, I have converted this raster to vector in terms of digitizing the same data with polygon feature, right? So how does it look like? Let us take a look. So this is how it looks like. So this is a vector, right? So I can simply switch the raster layer off, and now this is basically a vector. See, in raster layer, I just I can only visualize. I cannot select individual district, okay, because it's an image only, okay, it's a basic image only. But once I convert this, I can simply select the different district, okay. So this is how it looks like in a spatial domain, right? So we are seeing it spatially. Now just try to recall what I was telling you in the earlier session, that in GIS environment data can be stored in spatial format and as well as a non-spatial format. So what is a non-spatial data? If I simply go and open the database of this particular vector, I'll be seeing that I have attached many vector data, sorry, many non-spatial table. See, here all the district names are there, right? Then the respective areas are there, male population, female population, total population. So here I have only, just for example, I have only added few columns. But in real case you can add 100 number, 1000 number of columns, like age sex ratio, then what are the literacy rate of that particular district or any particular area, length, area, perimeter, many things you can go, and you can go for any kind of analysis. Say for instance, suppose quickly see the power of a vector data, or see the power of a GIS environment. I can simply quickly label this feature, okay. So it's now showing India, 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 because I have labeled the data with the country name. Simply I can change this to I can go to level fit and change this to the district name, and quickly I'll be able to see the district name. Now see how the map is getting interactive in a GIS environment. So now if I want to give different color to this district, I can simply go and change the symbology. So this is all about cartography. Why I was telling you so much about cartography. So earlier, in earlier days, cartography was not like that. So suppose I have drawn a map, then if I want to give red color to Darjeeling, I have to take a specular pencil, or I have to take a color pencil, or any watercolor. Then I have to color the entire thing, okay. Darjeeling is a different color, Jalpaiguri I have to show with yellow color. So here I don't have to take that much pain, right? It's a few matter of few clicks. So simply I can go, I can choose a color scheme here, and I can simply add this color to my map. See see if you don't like this color scheme, there are multiple number of color scheme that is available here. You can change to any color scheme of your choice, right? Simply I can change to different color scheme. Okay, if you think that okay, I'm not happy with the color of this, say for instance this Howrah district. Okay, so simply you can go here, you can change to a different color. See, so map is way interactive in this in a GIS environment, right? Now suppose let us go for some a few other examples. um, Let me just retrieve any data, any district that is having an area of more than like more than 6,000 square kilometer, right? So what I can do, I can simply make a query. So select by attribute, so area greater than equal to 6,000. See, look at the power of GIS. So simply I can make a query within a second, and there are total number of 4 districts here we can show, which is having the area of the district that is more than 6,000. What are the district? See, Purulia, Bankura, Midna, Bardhaman, Paschim Medinipur. Okay, so these are all the biggest 4 districts of our state that is having a area of more than 6,000 square kilometer. So you can simply save your query in a different layer. Okay, suppose I want to just save this particular district, so I can simply go to my layer, and I can go for selection, and I can create a layer from the this particular selection, and I can switch this off map. Okay, this is my this may be a new map for me. Okay, so what is a new map? New map for me that the district is having area of more than 6,000 square kilometer. So look at this, how easy it is. Huh? And simply name the district. Even I can give some different color to the district color scheme, as I was mentioning earlier. See, so you can also go for some other queries or some other kind of analysis. See, there are a lot of critical analysis that can be made within GS environment, but that would be not your area of interest. So let me take some simple example for you. Suppose I want to there are a bigger data, and I don't know the exact spelling of the name, and the name of the district. Okay, so I want to find out, so I can simply make a query. Or if I know the name properly, suppose I cannot find from the list. Okay, or I cannot go manually, and I cannot check, so I just want to check what is Kolkata. Okay, so what I can do, simply I can select by attribute district, like here I can type find Kolkata for me. So I have written a wrong expression. So there you go. Instantly Kolkata is selected, and if I go for zoom to layer, see, this is my Kolkata area. So this is how you can make many kind of query, many kind of search, and uh, you can go for many kind of analysis. So this is the way a map is interactive in a GIS environment. Because the best part is you can once you are making a query in the non-spatial table or the attribute table or the database, at the same time spatial it is also getting selected in the spatial domain, and case is also correct for the reverse. I mean, it's a vice versa. If you select anything in the spatial domain, it will be also selected in the non-spatial table. See, here it is automatically getting selected. So this is how it is working. So again I can make a different query, like show me the district where the male population is above 20 lakhs, right? So what I can do, simply I can go and select it by attribute, and uh, go for the male population, male greater than equal to, okay, so all the district are having male population about 20 lakhs. Okay, we can search in the reverse way, that is less than equal to 16. See, less than equal to 16 lakhs. So these are, are all the district where the main male population is less than equal to 16 lakhs. So Purulia, Birbhum, Dakshin Dinajpur, Uttar Dinajpur, Darjeeling, Jalpaiguri, and Coach Bihar. So I can select a different theme for that. I can overlay the same district with another layer by giving a different thematic expression, right? Just let me show you how you can do that. See, I can denote it with a different hatch, right? Suppose this one you can take. So simply I can overlay this district with hatches, or if you take some other example, like you can see with a dot. Okay, you can take it simply hatches. Okay, so you can use this same for your small schools projects, or sometimes representing your different geographical data, or if you are doing small project in your geography subject, you can take use of this kind of small analysis or software. Though it's a paid software at GIS, but there are a number of open source software that you can use for your academic purpose. Like I'll suggest a name, that is QGIS, Quantum GIS. It's a free software. It can be downloaded from your PC or laptop. So you can take use of that. The functionality is almost same. You can simply use that software for your project making purpose. So I want to show you another example of working with point data. Here we are discussing about the polygon, the district boundary or the state boundary. Suppose there are certain features, or that there are certain data that is to be represented by a point data. So likewise, I have a data for pin code or the post office. Okay, so you are aware of zip code or the pin code. So I'm having a lot of points. Okay, so they are actually representing the different post offices or different pin codes where it is exactly located, right? So these are all different pin codes. See, so now you can see and go from the attribute, check from the attribute that there are total 1691 pin codes getting represented in your West Bengal state. So now I want to see that what are the pin codes that is getting started with um, 700, because we know it very well. The 700 is the pin code of Kolkata, and all the pin codes of Kolkata used to start with the 700. So I can simply make a query here. Okay, see the power of GIS. So I can simply make a query pin code, uh, like so. 700 is mostly it is in Kolkata. There are few other pin codes that is also started with a 700. So I can put another zero. Then I think there will be only Kolkata's pin code. See, yes, mostly. Okay. So see, this is a beauty of your SQL. Basically, what I'm doing is I'm trying to search data with SQL. It is called a SQL query. structure query language you might have heard. Because nowadays you all are computer literate, like in our time we were not that much computer literate at your age, like in your 11th or in your plus 2. But nowadays you are very good at computer, like you are learning languages from your 10th standard, so you can understand or you can appreciate it better way. So this is how you can you can use SQL query for working in a GIS environment, right? So I can also come up with some other queries, like show me the pin code of a particular district. Say for instance, like Paschim Medinipur. Okay, so simply I can go for district equal to get unique values. From unique values, I can select my desired district, Medinipur. Okay, see. So all the pin codes of Midnapur district is just selected. You can simply export this particular layer, particular selected record as a different layer. You can share it to someone else. Okay, so this is how you do. Now, if you just know a particular pin code, suppose I just want to find a particular pin code. I have a parcel. I have seen my parcel, but I don't know where that pin code is located. But I know the pin code. Okay, so suppose let us take 713216. Okay, I don't know where it is located, so I can simply go and check 713216. I can use like operator because it might have stored in a text format. Yes, see, it is selected Durgapur RE College SO. So I can simply go to the Zoom record. See, it is in Durgapur. Okay, so suppose I am somebody has sent me a parcel. I'm a parcel operator. Somebody has sent me a parcel with a pin code written over there, but I don't know where that pin code is located, and I don't also have internet right with me. Okay, so what I can do, if I have a foolproof GIS environment, if I have a foolproof GIS database, I can simply search from that pin code. And best part is that here the concept of spatial domain is coming. I can simply search from the database. I can see the attribute, and as well as at the same time I can see the same thing on my map, since my map is geo referenced. Okay, I can see the exact point what is where it is located. Even if I want, I can take out the lat long of this particular place, right? I can simply take out the lat long of this particular place. I can click here and I can check the lat long. Okay, this is my lat long. So if I now want to find this place with the help of Google Earth, I can simply go and type my latitude and longitude in Google Earth, and I can fly to that particular area. See, so I hope now you are finding a little interest that the concept I was trying to show you. Another kind of study is very famous with a GIS environment, that is the change detection studies. Our world is a very dynamic place. Everything is changing. The river course used to get changed, right? The forest cover used to get changed. Sometimes it is increasing, sometimes it is decreasing. If you look at the agricultural land, it is also getting changed every day. If you look at the urban area, that is also getting changed. Suppose you just take an example of Kolkata, okay, or the urban fringe of the Kolkata area. That is a new town area, right? So if I go for the historical image means here I'm talking about a temporal image. In remote sensing there is a concept of temporal image. Suppose a satellite is continuously passing over your head. So now today if this satellite takes an image, after certain days, suppose after 20 days or 16 days or 15 days, the satellite will come again to that particular place. So now if I store the data one by one for a particular date, suppose in 2000 I have taken an image, 2010 I have taken another image, 2020 I have taken another image, 2025, 2020, 2030, 2050. So I can collect this series of image. Okay, we call it a time series data. I can take series of image and I can put it in a single data frame with I can georeference the image in a very well manner, and simply I can I can find out the changes, what are the changes happening in over the earth surface. Okay, so just if we take an example over here, so this is the condition in 2023. If we go back in 2010, you might be seeing that probably less number of buildings were there. You know, so that is the concept of urban area, because it used to change every after every 2 years, 3 years. Okay, or continuously it is getting changed, right? My internet is working a little slow. Let's just wait for a few minutes. Okay, now it has come. Now look at this area, okay, of Newtown. So in 2016, there is a vacant plot over here. It was the date of pass of the satellite was July 2016. So I'm going a little bit ahead, 2017. So 2018, see, still there is nothing, but only one building has come up. One new building has come up. Now look at 2018. So there are some construction we can see. So you can simply find out the changes. See, 2016. So there was no such big buildings, but once you come to 2018, 17, 18. See, these are the building, or there is some kind of construction is coming up. One high rise is also there, right? In 2018, but in 2016 it was not there, right? So now 18. Going little ahead. 19. See, now again some changes that has been occurred. 20. See, and two more buildings. 21. See, few other changes. See, 22, some other buildings. See, 20, 22, and again 23. Even if you look around, many things are getting changed, right? In this past 10 years or 20 years, many things are getting changed. If you look at this particular complex, see, look at this. This was entirely vacant land, right? So in 2017, some building has come up. 18. See, so they are developing a project. So we can simply map that using this satellite data. If we convert this data to a vector format, like with a polygon, if we make the building footprint separately, we can simply map this data. Likewise, if you this is all about man-made feature. So if you want to quantify the change due to a natural phenomena, just like for river course change, or for like changing in an island, right? So you might be knowing this particular location. This is the delta of Sundarban. It's a famous area, one of the world largest mangrove area. Now you see, this is the condition of a particular island in Sundarban in 2022, right? It's the current date. Now if I am having the access to the time series data, and if I go back to 2000, back to 2017, 15, 13. Well, so look at the image of satellite image of 2010, right? So this is Jammu Deep, or the Jammu Island. So if I try to polygonize this particular island, I'm taking a freehand tool, not going very precisely. Um,
Okay, so this is about, I can rename this with 2010. So now straight away come to the present day, right? So see how the island have changed. Okay, there is a drastic change in the island, and if you calculate the area, there will be a difference in the area also, right? So if I now draw another polygon, see. So this pink color boundary is for 2010, and this you know and this yellow color boundary is the for the present day, right? So look at the changes that has been occurred in last 12 or 13 years. So if I check, nowadays the area is, in square kilometer it is 3.56 kilometer square kilometer. And if we go to, uh, let me rename the feature, so 2023, and let me go to 2010. So in 2010, so it was 4.48 square kilometer, right? 4.48, from 4.48 to here it is 3.56. So it is a, you can just quantify the changes. Uh, So earlier it was, 4.58 minus 3.56. So there is a straight away change of 1.02 square kilometer in last 20 12 or 12 or 13 years, or in a particular decade. So it is a, we have just mapped the decadal changes of the this particular island. Okay, so this is a, there is a normal example of change detection and the area change detection that can be done using a GIS. So here I have shown you in Google Earth. You can do the same exercise with the help of a satellite imagery in a professional software like ArcGIS, or in a professional software like QGIS. So this is all about the changes. You can, there are a lot of animation that can made through the temporal satellite data, and I'll show you a little bit of that. So there is a famous place in a district of Jharkhand, that is Sahibganj. So it is just near to your Ganga river. It's just beside, located just beside the river Ganges. So here you can see, this hill is having a lot of mining areas. Okay, this is for stone mining. So we can see in 2001 there was no stone mines over here, no sign of excavation. But once I go in the timeline, once I change the timeline, you'll be seeing that over the period, like there will be a lot of changes. So see, the first changes that is getting identified over this particular place, right? So you go little beyond 2014, 15, 16. See, it has been increases a little bit. Okay, then 17, same, 18. See, some few more changes. 19, more changes. 20, again few changes. 21, 22, 23. Okay, so you can quantify these changes with the help of GIS, right? You can simply make the database one by one by creating a polygon, and you can store different polygon for different years, and you can actually make a trend. You can actually make calculate the trend of the change that is getting identified due to the mining activities. So actually there are a lot of examples that I can show you. Even you can animate these changes with the help of different software. I'll give you some glimpse of this particular example. See, there is a mining area. Okay, and see how it is getting changed. Look at the year. Okay, it is starting from 1984 and going for 2003, 4, 6, 5, 10, 11, 12, 13, 14,
15, 16, 21, 22. So see how the area is changing due to the mining activities. So this kind of change detection you can identify from remote sensing, remotely sense image, and you can quantify the same changes in a GIS environment, right? So that's why this remote sensing and GIS, as I told earlier, as I mentioned earlier, that these are all integrated science. So remote sensing is one of the important data input to your GIS environment, right? Another good example is there for glacier recitation. It's a very common phenomena nowadays, because due to the global warming, and due to the average heat increasing of average heat of the globe. So the glaciers are getting melted. See, you look at this, you just look at this place. Okay, the glacier, earlier in earlier time, glaciers was up to this particular place. Okay, but the over the period, the glaciers are, the going back, the snouts where from uh, uh, the droplets are coming. I mean, the where at the particular place where glacier is getting melted, and it is giving birth to a particular river. So that point is going backward, right? So that means you can see a global loss in the glacier. You can go for some other example, like river meandering. This is also very important activities. You can change, you can detect the changes of meandering in the Ganga river. See how it is changing, right? Coastal expansion, you can also see urban growth, as I told you. Okay, deforestation is also a very good example. That the Brazilian rainforest is an example of the tropical rainforest. And due to urbanization, due to huge expansion of city or urban population, people are cutting down the trees, and they are getting shifted to the that particular area. So that's why they are removing the forest. They are felling the trees. So that activities also can be monitored through remote sensing images, and it can be quantified in a GIS environment. See, look at this particular place. It was full of thick forest, right? And over the period, look at the timeline getting changed in the below your screen, in the bottom of your screen. And you can see the animation is done starting from 1984 to 2022. You can pause this and see, you can simply go one by one. 1984. Okay, let us go one by one. 84, 85, 86, 87, 88, 89. See how it is changing, you know. So this is a very good example of change detection. So there are many famous web portal that is based on data feeds and online feeds or the weather data. And by using those data with the help of a map, you can visualize your data with a very good animated representation. So Windy is a very good website to see the current wind situation. So I'll take you around to that particular site for a few minutes. So it's also basically a web GIS based So if there are any kind of the depression or in other activities, that can be also monitor from this particular website. So it is showing the data for the entire world. See, so this kind of WebGIS dashboard can also be made through using the GIS technologies, right? So there are a lot of examples in a single session or in a single video of 1 hour or so. The entire thing cannot be explained. So if you want, if you are interested to listen to many more, or if you're interested to see to many more facts, you can write to me. So we'll come up with some new session or new videos.
So, before I end the video, let me take you to the few facts. Uh, so, in the GIS domain where India is actually existing, so India has long been a leader in the using of modern spatial and GIS technologies. So, in early 2000, it took steps towards designing a national spatial data infrastructure, that is NSDI, where it was decided that all the government agencies and the semi-government agencies will be, depositing the entire database so that it can come up with a common database and for sharing the data to among the different government stakeholders, right? So there are a few more steps that you can read from this slide. Uh, there are few milestones that we have achieved uh, throughout. So from 2012 onwards. So in 2012, National Data Sharing and Accessibility Policy is introduced. Then Remote Sensing Data Policy is also introduced in 2012. Then 2013, government of India has come up with a cloud that is Megraj. It's maintained by NIC. Then hereafter in 2018, 20, 21, 22, the drone policies, then the draft of national geospatial policies, then national strategies for artificial intelligence or AI, which is a very common nowadays. It's the upcoming technologies and it's the future of not only in GIS domain, it's the future of in many domain, in the IT also. Then there are some few overview of few platforms of NIC. You can go through the slides. So I'll come up with the statistics of Indian geospatial market. So Indian geospatial commercial industry market in 2021 is estimated to be it was estimated to be the 14,050 crore, and afterward there is an expectation of 13.8% to 23,200 crore in 2025. Well, so let me end up with the possible career option in GIS. If you want to choose GIS as a future career option, so you can go for doing your masters in GIS after your graduation. Uh, mm, Preferably, you have to do your graduation from science background, or a BSc, a valid BSc degree. Then we can go for choosing your masters in GIS or remote sensing or geoinformatics, the same, because degrees are offered in different name. Somewhere in IITs it is geoinformatics, or in some other universities it is on remote sensing and GIS. And afterward you can choose your PhD. You can go for doing your PhD in the same domain also. And for career option, there are a lot of government agencies where you can join as a GIS analyst or GIS technician or scientists. And for private also, you have they're also having a lot of opening in GIS domain for programming, GIS development, GIS, and like analysts. And if you want to go for further higher studies, you can go to abroad and you can choose for postdoc and other uh, degrees. Okay, So, with that, I thank you very much for listening to my talk. And if you like it, if you like my video, please like the video and do subscribe to my channel. So, thank you.